Hello everyone. So today's tutorial will be about taking the analog voltage input and displaying it on the screen here. I have a module here that has a couple of potentiometers, a speaker, but I'm just going to be using this one potentiometer. So I got power and ground connected. Power supply is about 3.27, as you can see here. And this is the analog voltage output. I'm using the AN0 input here, and then this white wire is my ground reference going to the breadboard. Let me get this camera out of the way, and then I can start this project. Alright, so I'm working with an existing project, so if you have been watching my videos, the TouchGFX, the current version was 4.13.0, and then Q by DE is 1.2.1. There were some issues where you couldn't get the TouchGFX to compile or show any graphics on the LCD display, so I had to make a tutorial on how to get a project running. So this is the project I left off at. So if you haven't got a project up and running that's working, you'll need to follow that video. So I have a link to that video below. So from here we need to open up TouchGFX and get that program running. So again, this was from a previous project, so I'll just go ahead and select that toggle button, delete it. Let me change this to a dark background. I'm going to add text. Okay, and then I'm going to make that white text. And then uncheck this auto size and expand this out a little bit. I'm going to add a wildcard here, and then check this box. I'll just leave it as default, and then here I'll just name it ADC1 underscore N0. Space there, and then after value here, that's our wildcard. I'll put a V for the voltage. So go ahead and center this, and then because we're using a wildcard, we need to add wildcard characters here. So go under text here. This tab, topographies, and then since we're using for that text, it was the default, we need to add wildcard ranges. So that's going to be 0 through 9 because we're only using numbers, and then we need to add a decimal, so we'll just add a decimal here. Okay, so 0 through 9 and then a decimal. Go back to the canvas, so that should be okay. And just to check to make sure everything fits, I'll put in some value here. Alright, so let me put another, so I have a decimal of 3 places when I finish this project, so it all fits in here. Okay, so go ahead and delete that. Let's go ahead and and before I do that, I need to change this to text area AD. Give it a name. Alright, so go ahead and generate that code. Okay, that's done, so I can go ahead and close this. Then we need to go to the IOC file, double click that to open it. Alright, so let's set up the analog input, so ADC1 here. Move these out of the way. Alright, so we select N0 here. Alright, so go ahead and leave these at default. And then scan conversion mode will enable that. And then before I can select this, because right now the only thing has it disabled, I have to go to DMA settings. And we're going to add and select ADC1, and we're going to do a circular here. And the rest here is a default. So now I go back to parameter settings. Now I can enable DMA continuous request. And then let's see, here we'll do end of all conversions. And then here we're going to use timer 1, and that's going to be output out event. So timer 1 trigger out event. Everything else is going to be default. So now we can go to timers, use timer 1, okay. Use the channel 1, and then we're going to select output compare no output. Okay, and then we're going to set this up. So we're going to set this up for a 10 millisecond interrupt. So let's go to the clock configurations here. So our timer is off. Where is it at? Timer clock. So that's a 100 megahertz. So doing some research. So it seems like for every 1 megahertz, it's 1,000 ticks. So what we need to do, and it's kind of hard to explain, but we multiply 1,000 times whatever that frequency is to get like a 1 millisecond timing. But I want 10, but I will set that up in a second here. So since this is a 16-bit value, the highest I can go is 10,000. I can't do 100,000. So like again, like I said, the frequency is 100 megahertz, and then we times 1,000. But I can't do that, so I have to use 10,000, and then we'll do a -1, and then because I couldn't get 100,000 here, I have to it's kind of hard to explain, but to move over that 10 that I don't have here to here, and that I wanted a 10 millisecond interrupt, so add a 10 here plus our 10 that came from over here, and then do a -1, and then I'm going to enable the auto reload, preload, and then here go ahead, select update event. Oops, wrong one. Update event. Alright, so everything else is correct. Nothing else needs to be selected. Okay, so now close these out. Middleware, we need to add a task in the FreeRTOS and also a binary semaphore. So let's see, where's task at? There it is, task. So I added one. So call this task analog input. And then that was a task name, and this one was the function. So analog input. Everything else is default. And I need to add this binary semaphore, so timers and semaphores. Add. And this will be binary we'll just call it analog. So we'll use the binary semaphore to notify the view that there's a value that needs to be displayed on the GUI. Let's see. I believe that's it. I'll go ahead and save, and it'll generate the code. Alright, so now we can go to the core source and we'll open up main. Now, if you watched my previous videos, I try not to use or write any code in main. That being because there was a time where I was writing code mainly in the task. When I generated some code, the application crashed, and whatever I wrote, I couldn't recover. The main.c file was not recoverable, so I lost all my coding. So now I basically write a new, create a new file, and I call that. So I minimize what I write in the main.c. So let me go ahead and create a file, and this one I call polling routines .c. Okay, and then also include a header, polling routines .h. Alright, so now we can go back to main. Let's go back to the top. Then I'm going to add the header, the polling routines. Alright. Let's say that real quick. Alright. Here I'm going to write a couple functions. Void polling init. And then void polling routine. I'm going to add the prototypes here to the header file. Go back to main, and then I'm going to add those function calls in our new task that we created, which is right here. So the analog input. So I'm making a call, the polling routine within the for loop. And then this polling init only needs to get called once, so we'll add it before this for loop. Alright, so that's all I write in main.c is the polling init and polling routine, and then I add the header for here. So if this ever crashes, I don't lose any code. The CubeMX or the IOC file will never do anything with my file here, so I can write all my code here and not worry about it being overwritten or corrupted. Now from here we need to copy some variables here, so copy the ADC one here, add it to here, and this is going to be extern. Then I need to get the timer, and that's timer 1 here. This is also extern. Okay. And then the binary semaphore. Copy that. Extern. Alright, let me just save this. Alright, I need to, let's see. Oops. Alright, so I need to go to the drivers. HAL driver here, source, and then the ADC here. And then I need to look for this callback. And it's this one in here, conversion complete callback. So just highlight that and do a Control K, and I'll keep Control K until I get to that function. And here it is. So I need to copy this without the week. So Control C, go to polling routines, paste it at the bottom here. Alright. So we're done with that. As you can see, I like to save a lot. Alright, so now I need to add some headers here. Includes, I mean. Alright, so the CMSys, this is for the FreeRTOS. Without this, the compiler won't know what this semaphore ID is. Alright, so I need to create a variable to hold the ADC values. What I'm doing is, if you remember, I have the timer interrupt every 10 milliseconds. I want to hold 10 values. So every 10 milliseconds, value gets saved here. So after 10 values, that will equal 100 milliseconds. So every 100 milliseconds, or when all 10 indexes get filled, this callback gets called. So from here, we'll call the binary semaphore handle, and that will notify the view to update the display with a new voltage. So here, let's go ahead and paste some code here. Alright, so here I'm starting in the DMA. Passing this ADC handle, and then this variable that it's going to save all the values to. So we're just giving the address where this is at, and then we're telling this function that we want 10 values. And then here we're starting our timer interrupt. Alright, so when we get our 10 values, we get this callback interrupt, and from here we're going to notify the model that there's a ADD conversion already done. So we're going to pass we're going to notify the view. So from here we need to open up the GUI here, the source, the model, and then when this tick, we need to, let's see, give me a second here. We're looking for that binary semaphore. Okay. So couple more stuff here. Alright, so we need to include the FreeRTOS header here so it knows what this handle is. And then this is our ADD value that was in polling routines here. So we do an extern for both of these. So we're making sure that the binary analog handle here is defined. If not, then we don't enter here, but it is. So now we're just gonna wait from polling routines. We're releasing this binary semaphore, and in the model we're waiting to see if it was released. So if it is, then we're gonna call this function. So this function will be, give me a second here, is this function. Now I could do it all, I could do this within here, but I rather have it done separately. Okay, so here I'm creating a new variable sum. I'm doing a for loop, 10 iterations to get all 10 values that were in this variable, and I'm adding them all together. And here I'm dividing it by 10, the total of the indexes here. So this is going to be our average value, and then we're passing that to the model listener. So I need to let's see, here we go. It's like, where's my project explorer? All right, so let me go to, oh, I need to add this to the prototype, so I'll open that up, and then do a void analog update. All right. All right, so model listener is going to be under include. Okay, and model here, here's the model listener. And I need to copy this code, paste here. All right, so I'm creating another prototype, but this one has a curly brackets, no semicolon. And then I need to add, for some reason, this part of the file, when compiler doesn't know what the type is, so I need to define it. So we can do an include standard int library, or in most cases I can just use a main.h. So this type is known when the compiler builds a file or a project. So go close that. So we're going from the model to the model listener, and then it's going to go through the presenter. So let's go ahead and here's a screen one presenter, and we're going to create a function here. Oops. So screen one presenter, so that one, and we're going to do analog. Update, and now I'm remembering something here. Give me a second. Let's see, model. Oh yeah, we're passing the value. So here I need to receive the value. So 32, and it's gonna be value. Okay, so from the model we're receiving it, this value. I need to copy this and add it as a prototype. Screen one presenter. Alright. Close that. And then from screen one presenter, we're going to the view. So the view, and this is going to be the same thing, analog update. And I'm just passing the value. Alright. So go ahead and close that. And then we're going to screen one view. Add function. And this is going to be the same thing, analog update. And we're receiving the value. Right, and then I need to copy this into prototype here. Okay. Alright, so this is the view for the GUI. So from polling routines, when I get a callback after I get 10 values, releasing this binary semaphore, and then in the model we're getting this the FreeRTOS is ticking, so it's always checking to see if this binary semaphore has been released. If it has, then we call this analog update. I will take the 10 values here and sum them, and then divide by 10 to get the average, and then I pass it to the analog update through the model listener. From the model listener it goes to the presenter, and so this is our average, and then I'm passing this value to the view analog update, which is here. Alright, so here I will need to add string, and I'm going to do a memset. Alright, code. Alright, so again from this screen one presenter, passing this value to the view, which is here. So this is our value, this is our average. I'm taking this text area AD buffer, which is the wildcard, and I'm just clearing it to all zeros, and then this value, multiplying it with this number. This number is the voltage divided by the 12-bit registers, so it's going to be this value here. So that's our resolution, and then I'm only going to need 3 decimal places. So this is TouchGFX SN-printf for the float. You can't use the standard SN-print, it doesn't work. You have to use TouchGFX's SN-print floats. And then this text area AD is the GUI, so that will invalidate and refresh the value. Alright, also I need to add this as a prototype. Oh, it's already there. Alright. I believe that's it. Yeah, I think that's it. And here I'm not using polling routine. It was just something very simple. But if I had to do more stuff, then I could do from the main. This gets looped, so it's pretty much a task. But for this tutorial, I'm not using it. So let's go ahead and build this and see if I get any errors. Alright, let's see. It says redefinition. So defined here. Oh, already defined it here, so let me delete that. Try to compile again. So copied it from another project. So this is a capital B and this is a lowercase b, so it has to be the lowercase. Okay, let me build that. Has to be a lowercase too. and this one's lowercase. Sorry guys. Alright, looks like it built correctly. Let me go ahead and set up my camera here. I had to move out of the way to get my keyboard in front of me. Alright, let's see. So let's go ahead and start the debugger. Alright, ready to run. Alright, so there it is. ADC1 underscore N0, and then there's our voltage, and this, you know, the 3.26 whatever is our wildcard, and then our text that we had before and after is our here, so V's after. Let's see, so go ahead and adjust this. Let's see, it's adjusting. Alright, so it's the lowest. There's still some fluctuation. Let me go ahead and set up a voltmeter. So turn that up. So 0.865 is 0.86, close. A little bit more, 1.35, almost exact. 1.65, 2.1, so 3.26, so looks pretty good there. So that's how you set up analog input, how to use FreeRTOS to pass the value, and also to notify the view that there's a new conversion done. So we got 10 values at 10 milliseconds apart. So again, yeah, using the DMA, we want 10 values, saving this variable at 10 milliseconds each, so that turns out to be 100 milliseconds. So we get an interrupt every 100 milliseconds. So we then release this binary semaphore, and then here in the model we get a tick from the FreeRTOS, so this is always ticking, and so now it's always checking to see if this binary semaphore has been released. When it gets released, then we can call this analog update. And we're taking the 10 values here, summing it, and then we're dividing by 10 because that was the total amount, and we're in the average. And then from there we're passing it to the screen, screen one presenter. It does pass through the model. Now I forget what it was called. It was model listener, but it comes through here. So we get our average here, and then we're going to pass it to the view, this value. So from here we get our average, and then here we're taking that resolution that we calculated here, and times the value, and then we're using this TouchGFX STM32F for the float, and it saves it into this buffer, the wildcard buffer, and then we use this text area invalidate to update this text area. So if you like this video, give me a thumbs up. If there's any other tutorials that you like to see, let me know. Leave some comments below. Next project would be to use TouchGFX keyboard to input credentials, like for a Wi-Fi module. So here I have a ESP32 Bluetooth Wi-Fi module. I will show you how to have an edit text box to input SSID and the password, and then send that over UART to store it inside the ESP32 here. And then so when it powers up, it will connect to your router and then to the internet. And I actually have some code that actually checks for the weather, and it'll send information to this discovery kit, and then also get the time from the NTP server to update the time. So that will be in the next tutorial. Well, thank you very much.